This next publication review comes from the Journal of Neuropharmacology titled Pharmacology and Biotransformation Studies of 1-Acetyl Substituted Derivatives of D-Lysergic Acid Diethylamide, or LSD. The first compound studied in this publication is LSD. LSD is used as a reference compound so that we can compare our derivatives to the effects of LSD. ALD52. This compound is known as orange sunshine and was the LSD distributed by Nick Sands in the 1960s and 70s. It differs structurally from LSD in that instead of a hydrogen being attached to the nitrogen, there is a acetyl group. Next compound is 1P-LSD. 1P-LSD differs from LSD in that instead of a hydrogen being attached to the nitrogen, there is a propanyl group attached. The last compound studied is 1B-LSD, and once again, instead of a hydrogen being attached to the nitrogen in this position, there is a butanol group attached. So what we're really looking at is the effect of adding one carbon to the acetyl group, going from ALD52 to 1P-LSD to 1B-LSD. One carbon addition, how does that affect the pharmacology? The HTR or head twitch response of LSD and 1-acetyl substitute derivatives was measured in this study. The head twitch response is something I talked about in my video about mescaline analogs. If you give a psychedelic drug to a rat or a mouse, its head will twitch due to activation of the serotonin 2A receptor. The amount of head twitches it exhibits is correlated to how powerful the drug is. The more head twitches, the more powerful or potent the drug is. The first drug measured in this publication was LSD. This has an ED50 value measured to be 52.9 micrograms per kilogram. We talked about this idea that the ED50 is the concentration of drug needed to produce half the maximal response, and thus it is used to measure potency. A smaller or ED50 value closer to 0, the more potent the drug is. Its molar potency relative to LSD, or itself, is just 1. 1-acetyl LSD is ALD52, or orange sunshine, as we talked about. It has an ED50 value of 130.9 micrograms per kilogram. Because this value is greater, it is less potent. Its molar potency relative to LSD is 0.45. Thus, we can say that putting an acetyl group instead of a hydrogen on the amine reduces the potency by 55%, which is pretty drastic. 1-propanyl LSD has an ED50 value of 158.9 micrograms per kilogram. Its molar potency relative to LSD is 0.38, or we can think about this as a 62% decrease in potency from LSD. The last drug measured was 1-butanol LSD. 1-butanol LSD, or 1B-LSD, has a ED50 value of 457.6 micrograms per kilogram. Because this value is even smaller than that of 1-propanol or 1-acetyl LSD, it is the least potent of the drugs, and thus its molar potency relative to LSD is 0.14, or a 86% decrease in potency related to LSD. The conclusions we can draw from this are as follows. We saw that if we stick an acetyl position on the hydrogen where the amine is, we drop potency by 55. Then if we elongate that chain even further, the potency decreases. The researchers in this publication then wanted to understand how ALD52 and 1P-LSD are metabolized inside of the body. In this first table, the researchers have injected ALD52 into Sprague-Dawley rats at a dose of 0.1 and 0.3 milligrams per kilogram. Because we can see a detectable amount of LSD inside of the blood, this would indicate that ALD52 is metabolized into LSD. 1P-LSD tells the same story. If we inject 1p LSD into Sprague-Dawley rats at a dose of 0.1 and 0.3 milligrams per kilogram, because there is a detectable amount of LSD inside of the blood, this would indicate that 1p LSD is also metabolized into LSD. This next table is just trying to show all the possible metabolites both ALD52 and 1p LSD are metabolized into. If we inject an animal with ALD52, we can of course detect ALD52 inside of the blood, but we cannot detect 1p LSD, and we can detect LSD metabolites. Furthermore, if we inject 1p LSD into an animal, we cannot detect ALD52. This would indicate that the conversion of 1p LSD does not go through the ALD52 intermediate of cleaving off one carbon, but in fact goes through the intermediate of cleaving off the whole acetyl group. We see, of course, that if we inject 1p LSD, we can detect 1p LSD inside of the blood, and we can detect LSD inside of the blood. It's interesting to think about because when you take a drug like ALD52 or 1p LSD, when your body metabolizes those drugs into LSD, those LSD molecules will get inside of your brain and bind to the receptors. Thus, you're not really just experiencing one drug, you're also experiencing a few of the metabolites that are psychoactive. Let's now take a look at the binding affinity of LSD, ALD52, 1p LSD, and 1b LSD. At the serotonin 1A receptor, LSD has a Ki, or binding affinity, of 9.5 nanomolar, which isn't a particularly strong interaction between a drug and a receptor. But we should note that binding affinity doesn't necessarily correlate to the efficacy or potency of a drug. At the 2A receptor, we have 14.7 nanomolar. This is a weaker interaction. And at the 2C receptor, we have even a weaker interaction at 45.3 nanomolar. ALD52 shows pretty weak binding affinities at all serotonin subtype receptors. 1p LSD also has weak binding affinities at all the serotonin subtype receptors measured here. And 1b LSD, once again, also has pretty terrible binding affinities at these receptors. One thing I thought was important or interesting to note is that at the serotonin 1A receptor, as we go from ALD52 to 1p LSD to 1b LSD, we can see the binding affinity actually goes down, indicating a tighter binding when we take the acetyl chain and elongate it. This increases the affinity at the serotonin 1A receptor. Conversely, if we look at the serotonin 2C receptor, we can see that elongating the acetyl chain decreases affinity at 5-HT2C receptor. ALD52 displays dose-dependent increase in head twitch response. Let's look at the data to see. At a dose of 0 mg per kg of ALD52, we see a minimal HTR effect. As we increase the dose to 0.03 mg per kg, we see this effect increase. And at 0.1 mg per kg, we see an even greater effect in the HTR. At 0.3 mg per kg, we see the maximal effect exhibited by the head twitch response at the 30-minute time point. And at 1 mg per kg, the effect drops off. The researchers then want to see whether or not they could take away the effects of the HTR by using a selective serotonin 2A receptor antagonist, M100,907. To test this, they first injected the animal with no of this drug and just ALD52 and saw an effect for the head twitch response. In this assay right here, they took the experimental compound at 0.1 mg per kg of the selective serotonin 2A receptor antagonist and pre-injected the animal with it before injecting 0.3 mg per kg of ALD52. And when they did this, they see no effect in terms of the HTR, indicating that you can block the effects of the head twitch response exhibited by ALD52 if you pre-inject an animal with the selective serotonin 2A receptor antagonist. And in summary, there are three major key points I hope you understood from this video. The first is that elongating the carbon chain on the acetyl group of ALD52 decreases potency. We saw this in going from ALD52 to 1-P-LSD to 1-B-LSD. The second major key point is that the psychedelic effects of ALD52, 1-P-LSD, and 1-B-LSD are likely dependent on their metabolism to LSD. The idea here being that ALD52, 1-P-LSD, and 1-B-LSD showed fairly poor efficacy, potency, and receptor binding affinity to the serotonin subtypes of receptors when compared to LSD. And because they are metabolized to LSD, it is likely the case that their effects are mediated by this fact. And the third major key point is that the HTR can be blocked by the serotonin 2A antagonist M100-907. Thank you. Hope to speak again.